Okay, a very good morning. I speak to Dr. Ismail Ruby, Dr. Roshdi, and Dr. Asma. So today, first of all, I'm going to introduce myself first. My name is Ong Zi Jiang, and my matric number is 189983. Today, my FYP title is Refinement of Intermetallic Layer with Rice Husk Ash as Silica source in thin copper solders on bare copper surface, finished with laser soldering method. So for the introduction part, we have the background study, which is regarding the solders, which is has the purpose of forming bond to join the electronic packages with physical and thermal tolerable during the system cycles. And then we have the European Union proposed restriction of hazardous substance. Hence, we need to use lead-free solder with the same quality finish due to this restriction. Then we have RHA, which stands for Rice Husk Ash. Previous study shows that adding nanoparticles in very small amount will improve the mechanical strength of the solder joint. Then we have the laser soldering, which has the several properties such as rapid rise and fall temperature, non-contact soldering method, localized heat focus, and easy to be automated. Yeah, and then we have here comes the problem statement, which is we need to come up with the we need to come up with the soldering method which suitable for the miniaturization of the PCA or PCB, which can be used for the compact electronics. And then we need to come up with lead-free solders as a replacement of lead solder with same quality finish. Previous studies shows that SASC solders with the silver can have the almost same quality finish as the lead solder, but it is costly because the precious metal silver that has the unstable price makes the production costly. Then we need to retain the mechanical properties of the solder joint to ensure the solder joint performance. Here comes the objectives. In this project, we need to investigate the relationship of the RHA weightage in solder and the intermetallic compound thickness, or the IMC, formed for the multiple reflow. Then we need to determine the hardness of the solder joint with laser soldering. We also need to characterize the distribution of the RHA in the laser solder mark ecosystem. For this project scope, we are going to focus on the thin 0.7% copper with 0.01% and 0.05% and 0.1% of RHA reinforcement. Then the soldering method used is laser soldering, and the surface used is bare copper surface. And the multiple reflow has been carried out up to 3 times. So for the literature review part, it consists of all the key findings that has been used for the other chapters. Such parameters examples are the solder joint common needs, the factors affecting the good solder joint, the lead-free solder, the particles reinforcement and the IMC, and the composite solder and commitment, the laser soldering, the multiple reflow issue, and lastly the composite solder and hardness. So we can conclude from the literature review that thin 0.7% copper lead-free solder can save the cost without using precious metals compared to the SAC. So RHA particles should reduce the IMC formation. Then lastly, laser soldering should produce much thinner IMC compared to conventional oven reflow soldering. So for this methodology part, this is the research flow chart for my project. So firstly is the literature review study, and after that here comes the sample preparation, and after the preparation of the samples, we have the DSC and the FSM EDX to determine the melting point as well as the RHA distribution, followed by the soldering process, which are the laser soldering and the oven reflow, and multiple reflow has been done up to 3 times. After the soldering process, here comes the cross-sectional analysis, and metallographic preparation has been used to observe the IMC layer. And the methods to observe the IMC are optical microscope and the FSM EDX. And then we also have the mechanical testing, and Vickers micro hardness test has been carried out to obtain the hardness value of the solder joint. Then after that, all the data has been collected for the results and discussion part and thesis writing. So this table shows that the preparation of the samples for the ratio of tin, copper and RHA for 4 different weightage percentage of RHA. So as you can see, the copper weightage percentage are fixed, and then the RHA is vary from 0% to 0.1%, and then the others left are the tin. Okay, so here is the flow process flow of the sample preparation. First, mixing is done through the rotary ball mill, and it consists of the stainless steel ball inside the bottle to mix the powder thoroughly. Then after that, here comes the powder die compaction using the UTS, the universal testing machine, to compact the solder into a pellet shape. And then this is the FSM and DSC to determine the RHA distribution as well as the melting temperature of the solder that we have produced. After that, here comes the soldering part that we have used laser to solder the solder on the surface, bare copper surface, as well as the oven reflow. After that, here comes the cold melting to fix the samples in one place, and then for the grinding using several different types of grids, and then followed by polishing. After that, it will be sent for the optical microscope and the FSM EDX to observe on the IMC layer. So this is the soldering procedures for the soldering part. It is for the laser soldering and for the oven reflow, both also same. So we have 4 different percentage of the RHA, and then we have first reflow and third reflow, and we have 3 samples each for first reflow and third reflow, and for the different weightage percentage of the RHA. So in total, I will have 48 samples for the overall project. Here comes the methodology used for the observation of results. Here, first, we have optical microscope, and then we have the FSM EDX, which stands for Field Emission Scanning Electron Microscopy, and then the EDX stands for Energy Dispersive X-ray Identification. And then we have used the spot identification as well as the area mapping of the EDX to observe on the IMC layer. Then we have the Rickers micro-hardness testing to determine the hardness value of the IMC layer. Here comes the result and discussion parts. Firstly, the DSC result shows that the 0.01% RHA solder has the peak temperature of 235.23 degrees Celsius, and then the 0.05% RHA has the peak temperature of 234.56 degrees Celsius. Comparing to the plain tin 0.7% copper done by Chuan in 2019, the peak temperature is 233.62 degrees Celsius, which means that the addition of the RHA is causing the melting temperature to slightly rise. Yeah, and then here is the FSM EDX result of the RHA. So this EDX result shows that the compound from the RHA found in the RHA powder is the silica, or also known as SiO2, after calculations done on the weightage percentage or the atomic percentage of the elements found inside the RHA powder. So this is same with the title, so that the to confirm that the silica is sourced from the RHA powder. So this is the RHA distribution done from the area mapping of the solder pellet. So at the left hand side, you can see that this is the silicon matrix, this is the tin matrix, and this is the label RHA found on the surface of the solder pellet. So this is the wetting angle analysis. We can clearly see that from the results obtained, the wetting angle for oven reflow is higher than the laser soldering method. And then for oven reflow method, the tin 0.7%, the plain solder has 52 degree of the wetting angle, comparing to addition of 0.1% RHA that has 41 degree of the wetting angle, which means there is about 20% in decrease after addition of the RHA. So the laser soldering method is 28 degree for the plain solder and 23 degree after the addition of the RHA. So this is the IMC layer determination of the Cu6SN5 compound and as well as the Cu3SN. This can be determined through the spot identification of the FASM index and then calculate through the weightage percentage or the atomic percentage of the elements found in that spot. So this is the observation done under the optical microscope under 50 times magnifications. So we can see that the white, not white but grayish white layer is the Cu6SN5 layer, and then below that layer it is the Cu3SN layer, and we can compare the oven reflow method with the laser soldering method. We can clearly see that the oven reflow method results in much thicker IMC layer compared to the laser soldering method. So we also can observe the needle shape of formation of the Cu6SN5 through the observation under the area mapping to observe the copper element from the IMC layer. So figure C and D can observe the Cu6SN5 copper elements to confirm that there is needle shape formation of Cu6SN5. And then for the IMC layer thickness, this is the comparison of the area of the and as well as the ratio of the Cu-SN5 to Cu3SN of the laser soldering and oven reflow for the third reflow. So this one is the thickness, the total thickness of the laser soldering method compared to the oven reflow method. So we can, from the result obtained, we can clearly see that the laser soldering method has about 42% of the less thickness compared to oven reflow conventional method. Lastly, this is the hardness value obtained from the hardness test of the Vickers micro hardness test. So from the chart obtained, there is not much clear trend of the hardness value, but there is a very clear trend that the laser soldering method has higher hardness value compared to the conventional oven reflow methods. Okay, so here comes the society impact. The lead-free solder will result in safer environment, and it is much more user-friendly, and it is more economically affordable due to the abundant source of the RHA, and then it has the same or better performance compared to lead solder, and it has the mechanical as well as thermal properties advantages, and we want to have the strong solder joint. So here comes the conclusion and recommendation. In conclusion, RHA addition produce melting range of 18 degrees Celsius and have a peak temperature of 235 degrees Celsius. And wetting angle has been reduced about 20% with the RHA addition. And furthermore, multiple refill, for sure it will increase the IMC thickness, but in our study, the laser soldering IMC is much more thinner than the oven reflow IMC for about 42% after 3 reflows. And there is no significant hardness difference for the different weightage percentage of RHA. However, the laser soldering hardness value is higher than the oven reflow hardness for about 30%. Next, the recommendations are maybe we can try on the increase of the RHA weightage percentage up to 0.2%. Maybe we can have more surface trials. Maybe we can have less reflective solder for laser soldering, alternative solder preparation, maybe solder paste, and maybe we can try on the laser target temperature determination. And for the society implication, RHA usage is economically friendly and easily found, and more advancement will be needed to compete with the lead solders. And then lastly, laser soldering is becoming a trend in electronics production due to its automation programmable ability. So these are the references that has been used for these presentations, and that's all from me. Thank you.
Okay, thank you all. Question from Dr. Rusdi or Dr. Ruby?
Okay, how do you measure the weight of the RSA? Because you measure 0.2%.
Oh, I measure the weight of the RHA using the microelectronic scale that found in the ITMA lab at the mixing lab. Yeah. So the sensitivity is up to 0.001 gram. Yes.
Do you explain why the hardness of the laser is higher, 30% compared to the map oven?
For the hardness test, because the laser soldering is producing the much thinner IMC, and it should has the greater strength compared to the oven reflow, because the IMC thickness is different, and the laser soldering has a very quick soldering process, thus resulting in the hardness is greater compared to the oven reflow method.
But you need to use the scientific method that you have learned in engineering material in order to explain that.
For the hardness test, because I am using the Vickers micro hardness test machine to find the hardness value. So from the data obtained, we can observe that laser soldering is having the greater hardness value compared to the oven reflow. Yeah, and also from the literature review shows that if the component or the substance is having higher Young's modulus, it will result in higher hardness compared to the other substances. Yeah.
Okay, in electronic, do we need very hard or soft for the joint?
For the solder joint, it should be
Yes.
hard. It should be hard because after the usage of like for cell phones, if we drop it in on the floor, there is a sudden impact happen on the electronics. Thus, the solder joint should be strong enough and hard enough to join the electronics together, but not brittle. Yeah.
Because if too hard, it's become brittle.
Yes. So
So you need to explain about the balance between brittle and ductile for the solder.
I see. Because from the previous the literature I've done, the Young's modulus should be higher. Yeah. So so it will result in higher hardness as well. But we don't want the IMC to be brittle, because IMC it itself is brittle, and we don't want it to be very much. So we want to reduce the IMC layer.
Okay, Ong.
Okay,
Yes.
questions from Dr. Ruby?
Okay, Ong. I see your flow chart. It seems like so it's not simple. Can you make it more simple flow chart to represent your methodology? It's quite confusing actually. It seems so complicated here.
Because actually the preparation part is over here, and then this one is the observation part. Yeah. This is the
Observation
IMC.
part, you mean that the flow chart representing the methodology flow, right?
Yes.
Can you simplify it to become much more easier to understand? Whereas here, it seems that the arrow for interface profile, interface intermetallic elements needs to go up, but it doesn't mean it doesn't seem it will go up, right, to the hardness test, right?
Uh, you mean
Uh,
this part?
I mean, yeah, I mean the arrow is seems all goes down, but
Oh, yeah, it is go down because this is the value obtained, and it goes all the values obtained or the results obtained will goes to the results and discussion and thesis writing.
So please simplify this flowchart to make it much more easier to understand. And then the symbol, the symbol of the shape,
Uh,
okay, has its own meaning.
yes, yes.
If I'm
Yes.
asking you this inclined rectangle, do you have any specific meaning for that?
Yeah,
I guess.
for this shape, it means that it is some kind of input or output. So, example, for this hardness value, it is the output from the weakest micro hardness test, and it is the input for the results and discussion part. Yeah, so it same goes all to the all the results obtained from the observation.
So I hope you can simplify this to become much more easier, to much more clearer view for the reader. Okay.
Okay. I will try my best. After this, I will try to amend the flowchart again.
Yeah. And then for the objective, okay, it seems you have 3 objectives.
Yes.
Yes. Can you show me back the objective?
Yeah, this one.
Okay, to investigate, this one to determine, to characterize. Okay, so this one is okay, but for the when we go back to when we refer to conclusion, please rearrange the contents for conclusion according to the objective
Okay,
to make it
okay.
clear you with what your outcome.
Okay.
I I
Yeah,
I,
this one.
I comment to your thesis, yeah,
Oh, okay.
in thesis especially.
Okay.
So it's fine with the objective, but rearrange the
Okay.
structure content.
Okay. Okay, noted.
Alright.
Thank you, doctor.
Okay, thank you. Our time is up. 11:55. We have to go for Shafiq's presentation.
Okay, thank you.
Okay, thank you so much, Dr.
Okay.
Ruby, Dr. Rusdi. Okay, thank you all. Okay, bye.
Thank you. Thank you. Bye.